Hi everyone, welcome to the video number 5 of this series, and today we will be going to discuss about equivalence propositional laws. So there are many laws, but we have took some 12 laws, and from those laws we will be going to solve different type of logical statements. Okay, so now these are some of the laws mentioned here, and after that, like total 6 are here, but I will erase it and I will write more. Okay, so how I will explain this, I will take one and I will use this portion of the board, and then I will be going to explain it that why this LHS is equals to RHS. Okay, and slowly we will do all of them, and then we will erase, and then next batch the next 6 we will do. Okay, great. So first of all, we are having here two equations, and that are also known as properties of zero. Okay, so here we are ending and here we are oring. So we know that anything we will end with anything we will or with 0, that will be going to give you that particular variable. For example, what I am trying to say is I am writing here 0 plus p equals to p. So p is a variable and it could be any a, b, c, d, x, y, that you can take any. So I am taking p here. Okay, so what I am trying to say that whatever the value of p is, it can be 0 or it can be 1. Okay, that will be going to give you p. For example, what is 0 plus 0? Is nothing but 0. What is 0 plus 1? 0 or 1? It's 1. So here if you can see that this is p, so the same thing is coming in RHS. 0 is here, 0 is coming. 1 is here, 1 is coming. So that's the reason when 0 is, when we do oring of 0 with any variable, so it will be going to give you that variable only. Right? So that's the reason this law is applicable here. Now one another law is that when you do ending of 0. Okay, for example, instead of or, if I will do ending, okay, so I am just erasing the or and I am putting the end, the dot sign, right? So we already know that the p can be have two values, either it can be true, which means 1, or either it can be false, which means 0, right? So 0 when or 0 when end with 0, we know that it will be going to give you 0 only. When 0 when it ended with 1, again it will be going to give you 0 only. So that's the reason this law is there, that whenever we end, this is end, okay, AND operator, whenever we will AND 0 with any of the variable, so the resultant will be going to 0. So that's the properties of 0. Now you can also do this with the help of a logic gate. For example, if I will be going to use, I am using here OR gate. Okay, 2 input OR gate. Now the first input I will give 0 and second is p. So when we OR the 0 in p, so the resultant will be p only. Similarly you can do for ending this one. When you ended 0 with a p variable, so resultant will be going to come as 0. When I will discuss about logic gates, so I will discuss in more depth, but right now I think you understand both the equations. Okay, now let's move to this one. Second one. Now properties of 1, we have seen the property of 0, both are zeros. Now here both are 1. Okay, now see what will happen when we OR when we OR 1 with a variable. Okay, so now 1 plus p, it will be going to 1 or p is equals to it will be going to give you 1 only. Why? Simple, we already know that p can have two values, p can either have 0 or p can have either 1. So 1 we OR with 0 or 1 we OR with 1, it will be going to give you 1 only, because coming to OR gate, we know the OR logic that any one statement must be true, not all the statements. Although all the statements are true, then it will be going to give you true only, but if one statement is true, then also it will be going to give you true. So that's the reason 1 plus p is equals to 1. Now 1 dot p is equals to 1, this is AND actually, 1 and p is equals to p. Why it is there? See, so if we already know that the value of p can be 0 or 1, true or false. So if 1 ANDed with 0, it is going to give you 0. If 1 ANDed with 1, it will be going to give you 1, right? So we already knows that key. Okay, so if we are ending with 0, if we are ending with 1, so it will be going to give you 0 and 1 only. For example, if this is p, here 0 1, so you can see that in the output also you are having p as 0 1. So that's the reason, 1 dot p is equals to p. Okay. If you have any confusion, you please ask me in the comment section also. I will reply it. Okay. Now I am erasing this. Now next, absorption law. Okay. Let's discuss it. P plus PQ is equals to P. So many students get a bit a confusion here that how this is possible. So there's a very simple thing. The P is here, we can take it out common. Okay. So P, if I am taking out common, so in this place of P I can have to write 1 and then this OR, and then I will remove this P and I will put Q here. Okay. Now you can see that from this law, properties of 1, that any variable when it OR with 1, so it will be going to give you 1. So instead of 1 plus Q, I can write 1. So I am writing here P and I am writing 1 here. So when we P dot with 1, it will be going to give you P. Right. So that's the reason P plus PQ is P. And this is known as the absorption law. So, if you change the sign, for example, instead of here we are having OR, you change to AND, and here you are having AND, I am putting dot here, when you are changing to OR. Okay. And then also the resultant will be going to P. So when we interchange from OR to AND 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 to OR, the equation will be going to give you the same result. That means it is valid as per the law. For example, if I am writing here P dot P plus Q, okay, so what it will be going to become? Well, it will be going to become P dot P, right? I can write like this also, PP plus PQ. Now P dot P I can write as P, because from here, I think we didn't discuss that. Yeah, we didn't discuss it. Let me tell you, x dot x is equals to x. Okay, any variable when we AND it with that same variable, it will be going to give you that value only. Let me prove it. For example, x is 0. So 0 dot 0 is nothing but 0. 1 dot 1 is nothing but, I think we have did it. We did here, but not in that way. No issue, I will redo it. 1 dot 1 is going to give you 1. Okay. So here in place of y we are having 1. So the resultant is coming here y, here it is coming 1. Here in the places of x we are having 0 0. So the dot of 0 0 is nothing but 0. So that's the reason here 0 is coming and here the x is there. So I think you got it out what I am trying to say. You can write P dot P as P. Okay. So P plus PQ, again same thing that we did here. Take the P common. Okay. So it will be going to give you 1 plus Q, which is nothing but 1 plus Q from here, properties of 1. It is nothing but 1, right? So P dot 1 is nothing but P. Okay. So this is how this absorption law works. So this is about the absorption law. Okay. Now we are having involution. Now what is involution? We know about not get. In our previous video also we have discussed about not. That is nothing but the negation or opposite. Okay. For example, let's say I have a variable A and A is having some values. Let's say A is having two values, 0 and 1. Okay. So now what is the complement of A? Now in order to find the complement, we have to reverse it. What we have to reverse? 0 to 1, and we have to reverse the 1 to 0. For example, I have to write a complement sign, or I can put bar here. Bar is valid. I told you in the previous video that A complement, A bar, or A like to the power C. So these are all refer to the complement. One more is, few more are there, like this is also a complement, this is also a complement. So these are not, they are representing the not operator. Okay. So now what is the not of 0? It is nothing but 1. What is not of 1? It is nothing but 0. Okay. So if I do not of A not, means I have to put double not there. So now I have to reverse this one, right? So the 1 will become what? 0, and the 0 will become what? 1, right? So if you will see that A is equals to A complements complement. So P's complement is equals to P. That is known as involution, right? So you can also think about like this. For example, you are having a not get, you are having a not, okay, and you are giving it input. For example, you are giving it 0, and the resultant will be 1. Okay, but if you put one more not get here, okay, now this 1 will again change. Now it will become 0. So you can see that the input that you have given, that same input you can have in the output also when you are negating it for the 2 times. Okay, it's very important in evolution. And like these laws are very important because whenever you will solve the truth table or you will solve any of the equation using the algebraic expressions, Boolean algebra, so then these are very much important. You should know how these laws work in order to work on them. Now let's do next one, which is idempotence. Now between the lecture I will be going to also give you some of the definitions. For example, when I'm writing when I am saying equivalence, okay, it means that from the word equivalence, equal, that what we can grab out. So for example, if I want to say that two sides, for example, this is the left side and this is the right side, if they are equivalent or not, so I can use the equivalence. Okay, there is one more term which is known as identical. The meaning of identical is same. Okay, for example, let's say two values are identical, for example x and y. You made the truth table and you find it out that the value of x is coming 0 0 1 1 and the value of y is also coming same 0 0 1 1. So you can call it they are identical or equivalent or equivalence. So these are very important terminologies. So one is trivial in computer science. Trivial means something which is very easy, like computer science is very easy. So you can say that CS is trivial. So something like trivial means something which is very easy. Okay, so some of the terminologies. Okay, now next is idempotence. So there are two properties, that P or with P will be going to give you P. If I will change the sign, P and with P, it will be going to give you P. Okay, now this is known as idempotence. You can use it logic gate also to solve it. For example, OR is there, let me make it OR, AND is there, let me make it AND. Now we are giving here P. Now P is same here, it's not P and Q, it's just P. Means if we are giving 0, so we have to give 0 here also. If we are giving 1, that means we have to give 1 there also, right? So if I am giving 1 1 here, or let's say 1 1 here also, so you can see that 1 plus 1 or 1 or 1 will be going to give you 1, right? Similarly, if I AND 1 with 1, so it will be going to again give me 1. So what is 1 here? Let's say 1 is P. Okay, P is 1. Okay, so you can see that in the output also you are getting 1 only. So that's the reason they are equivalent. So P when OR with P, it is giving P. P when ANDed with P, it is giving P. Okay, so that is idempotence. Now sixth one, which is complementarity, or complementarity. It's very nice, like I really like it because of how it behaves. Okay, so now see, P plus P prime is there, which is equals to 1, and P dot or P AND with P prime, it is going to give you 0. Okay, now see, the idea is that we already know that anything we OR with 1, okay, it will be going to give you 1 only. If you will, you can OR either 0 or you can OR 1. Okay, it will be going to give you 1. And you already know that when we ANDed anything with 0, irrespective of it 0 or 1, it will be going to give you 0. Anything ANDed with 0, it will be going to give you 0 only. So this we know. So this is the same concept, we can use it here. Okay, let me make a truth table. All right, so yeah, so P, let's say I have P here, 0 1. So what is the complement of P? 0 will become 1 and 1 will become 0. Now let's OR both of them. 0 plus 1 is 1 and 1 plus 0 is again 1, right? So 1 is coming in both the sides, that's the reason it is coming equal 1. Similarly, if I have P and P value is 0 and 1, and if I am taking out again P complement, so 0 will become 1 and 1 will become 0. If I will be going to AND it, so 0 and 1 is 0 and 1 and 0 is again 0, right? That's the reason here equivalent RHS is coming 0. Okay, so these are the complementary laws. Now let's see the next 6 laws and we will complete whole 12.